Okay, welcome to the fourth in a series of mole calculations, and today we are going to be looking at the topic of titration calculations. Now, because it's quite a tricky topic, a lot of people find this rather difficult, I've enlisted the help of a member of your set, James Smith. Say hello, James. Okay, so Jamie is going to help me looking at titration calculations and how they're done. So the first thing, Jamie, what are we doing with titration calculations? What is a titration?
A calculation to work out moles and not really sure.
Okay, right, well that's a good start. But it's calculations to work out quantities. But here's the key thing, it's in, we lost you there, it's in solution. So calculations in solution are important because so far what we've looked at is we've looked at solids, we're now going to look at solutions. So, right Jamie, here's something you can do. If we take a solution here, and this solution is, let's say, some acid, doesn't matter which acid, there are two things that I can measure about that quantity of acid. What are those two things?
pH.
You could mention the pH, but that's not really a quantity we're going to look to measure.
Volume.
Good. Volume is one thing. And the thing is with volume is the amount of stuff. But what you know about an acid has something else as well as volume, because of course it's dissolved in water. If it's a large amount of acid dissolved in water, it's not got a larger volume, it's got a larger what?
Concentration.
It's got a large concentration. So the concentration talks about how much acid's actually dissolved in the water, and the volume talks about how much actual stuff there is. Okay? What we measure volume in centimetres cubed, and we measure concentration in the number of moles per decimetre cubed. Okay, so there's two slightly different units there. Concentration is in moles per decimetre cubed and volume is in centimetres cubed. Right, now one important thing we're going to look at here is we need to look at moles. What does moles equal when we're talking about solutions?
If
you go back, we've just looked at those two things. We've looked at volume and we've looked at concentration. Moles equals?
Volume times concentration.
Not quite. Volume times concentration
over
divided by
100, isn't it? Or 1,000?
It's 1,000. Okay, now that's a formula we're going to need to learn. We're going to need to learn that formula. Moles equals volume times concentration over 1,000. If you remember what moles actually are, a mole is a number. A mole's that really big number.
Yeah.
Okay.
Yeah.
What is a volume? Volume we measure in what units?
Centimetres cubed.
And can you remember what units we measure concentration in?
Moles
per
decimetre
cubed. Okay, that's actually incidentally why the 1,000 is in there. The reason the 1,000's in there is because we've got centimetres cubed here, we've got moles per decimetre cubed here. Right, so that's the equation we're going to use all the time. Now, often, when we look to use titration calculations, what we're going to do is we're going to look at reactions between acids and alkalis. Anything in solution you can use, but acids and alkalis are very common substances used in solutions. All right? Let's have a look at a common acid. We'll have a look at HCl. Let's have a look at a common alkali. We'll look at NaOH. When an acid reacts with an alkali, what type of reaction do we get?
Neutralisation.
You get a neutralisation reaction, and can you remember what type of substance we form?
Base.
Nope. It's acid plus alkali gives... Yep, you're on the right line. Salt. What type of salt are we going to get here? Name the salt.
Sodium chloride.
Sodium chloride, and we need something else as well because we've got this and this.
Water.
H2O. Okay, so that's our equation. Now, what our equation tells us, stick with us, Jamie.
Yeah.
What our equation tells us is that one of these reacts with one of these to make one of these and one of these. You call it a 1-to-1 to 1-to-1 ratio. Okay? So if I had 1 mole of HCl, how many moles of NaOH would it react with?
1.
And if I had 10 moles of HCl?
10.
Okay, so the ratio is consistent, 1-to-1 to 1-to-1, etc. So if I know the moles of HCl, I can work out the moles of NaOH. Clear?
Yeah.
Okay, let's have a look at an example. Let us say that we're doing this reaction, and we'll remind ourselves of the reaction because we've got NaOH, right, the other way around this time, NaOH plus HCl goes to NaCl plus H2O. Remember, that gives us the ratio. If we take, in a conical flask, if we take 25 centimetres cubed of HCl, what have I measured? What type of measurement is that?
Volume.
We know a volume, but of course we don't know the concentration, and if we don't know the concentration, then we can't work out moles.
Yeah.
Now, what type of apparatus would I put the alkali in to do a titration? If you can't remember the name of it, tell me what it looks like. Would I just add it from a beaker?
No.
What type of apparatus do I use in that case?
Would it be...
When you watch this back, Jamie, you're going to find you say a lot.
Yeah.
Okay, come on. What type of apparatus do we use? How do we get it in there? If I start drawing it, you need to tell me what it's going to look like.
It's not a thistle funnel.
It's not a thistle funnel, you're correct there. Do you remember what this type of apparatus is called? Basically, it's got a tap on the bottom, and it's a very long glass piece of apparatus, and it's called a burette. This is called a burette. Now, in the burette, excuse me, we put the alkali, and what we do is we open this tap, and what happens is the alkali drips into the acid.
Okay.
Now, what we do is we know the concentration of the alkali. Okay? Let's say the concentration of the alkali is 1 mole per decimetre cubed. That's the concentration.
Yeah.
Now, how might we know when this reaction has finished? We drip the alkali into the acid. How do we know when it's finished?
When the solution stopped fizzing. Or
No, it's not going to fizz. Why would it fizz? Acid plus alkali, it's a neutralisation reaction. How are we going to know that the reaction is complete? When you add an acid to an alkali?
Stop changing colour.
It does change colour, but the thing is acids are colourless and alkalis are colourless, so what do you use to make it change colour?
Universal indicator.
Not universal, but you use an indicator. Okay, it's not universal, because universal goes through lots of different colour changes.
Okay.
Right, the idea is we get a colour change. Now, when we add the alkali to the acid and we stop it, what we do is we know the volume of the alkali we've had to add, because we can read it off the burette. And let's just say that was 20 centimetres cubed. Okay?
Mm-hmm.
Now, if I know the concentration and the volume of the alkali, what can I work out?
The moles. So
I can work out the moles. Good. If I know the moles of alkali, what can I work out?
the
If I know the moles of alkali, what can I work out?
the moles of the acid.
Because they're in a 1-to-1 ratio.
Yeah.
And if I know the moles of the acid, and I know the volume, I can work out the concentration, and that's the whole point of this.
Yeah.
Okay, let's just do that. Let's remind ourselves of the equation. We've got a minute and a half, Jane. We've got to make sure this finishes by 10 minutes, because no one's going to watch it otherwise. Acid plus alkali goes to salt plus water. Ratio 1, 1, 1, 1. Right, we said, just looking back, we said that the alkali was 1 mole per decimetre cubed. 1 mole per decimetre cubed. You see, it's hard to write this thing. The alkali, we said, was 20 centimetres cubed. And we said the acid was 25 centimetres cubed. So the first thing we're going to do is we're going to work out, just like you said before, moles of NaOH. Moles of NaOH is equal to what?
Concentration times volume.
Concentration times volume.
Over 1,000.
Over 1,000. If you can't do it in your head, it doesn't matter, put it in a calculator. That's 2 times 10 to the minus 2. I'll tell you what, actually, let's just write that as 0.02. Okay? 0.02. Number 2. Moles of HCl is equal to?
Volume times concentration.
No, come on. Ratio is
1 to 1.
1 to 1. So if
So
we've got
it's still-
0.02 moles of this, how many moles of acid have we got?
0.02.
It's 1 to 1. So whatever moles of this we've got, they'll be the same as the moles of this, yeah? Right, last thing, slightly more difficult. If moles of HCl is 0.02, what we know is that putting this into the equation for HCl, okay, just concentrate on this bit, putting this into the equation for HCl, moles is 0.02, which is equal to volume. What was the volume of HCl?
25.
0.02 is equal to 25 times concentration, which we don't know, divided by 1000. Therefore, concentration equals
0.02 times 25,000.
nope.
Oh.
How do you get the 1000 over to the left-hand side?
You times it.
So 0.02 times 1000 divided by 25. So that's 20 divided by 25. Do you know what that is?
4 over 5 would be 0.8, is it?
0.8. And in 11 minutes and 18 seconds, that is the correct answer. Okay? Well done, Jamie.
Thanks, sir.
Say goodbye.
Bye, guys.